Hello and assalamualaikum guys, welcome to another video of study with ARS. Today's our topic is ionization, energy and electron affinity. We will be means and delivering this lecture and very deep. Okay, so hope you will be understanding it very quickly. Okay, so let's start without wasting our time. So electron means ionization energy is the process in which the minimum energy is required, means the minimum energy is required is required to remove an isolated electron remove remove from the outer shell remove from the outer shell from the outer shell of an gaseous atom of a gaseous atom. Okay, means that for example of ionization energy is this, that like we got magnesium here. Magnesium is a metal, and as it ionization energy is usually happen in metal as compared to non-metal, because I will be telling you reason after this example. Okay, example. Okay, like magnesium is having 11 not 11 12 electron. In first it is having 2, in second it is having 8, and in the third shell, means KLM shell, it is having 2. So there are 12 electron. 2 plus 8 equals to 10, 10 plus 2 equals to 12. So for example, if magnesium performs the ionization energy, then how can it perform? So definitely magnesium, we have to give some energy to magnesium to lose its electron. So when we will be giving energy, for example, we have given energy. Okay, we have given energy 738 kilojoule per mole. This is the energy required to remove electron of a uh, magnesium metal from its last shell. So one electron will only be there in M shell, and one electron will be moved out from the magnesium. So this one electron will be called as free electron, and now this become magnesium become an ion, and it is having +1 charge, means it has loses one electron and someone can get from it, means it's a free electron. It doesn't matter that who is gaining this electron, but magnesium has lost this electron, and now it will be called as Mg+1 ion. And if you talk about if magnesium will loses Mg+1, which is ion, will loses one more electron, then how can it be possible? So if we will be giving energy up to 1450 kilojoule per mole, then this energy means is required to remove the second electron, which is this one, means this is was the reactant. Okay, so here we were having 2 electron in the first, 8 in the second, and the last one in the third. So if we need to means remove this electron, so how can we? So when we will be providing this amount of energy to the magnesium, so it will be losing its electron and will become and will become Mg+2. Mg+2 is an ion. Okay, plus plus, it is a magnesium ion. So it means it will be like this, and magnesium will be losing its electron, and it will be a free electron. Okay, so both here we have the free electron. Okay, so means we are giving energy here and here. So to give energy is considered as an endothermic reaction, means they are absorbing energy. Their heat content will be in the positive. Okay, heat content means enthalpy means the heat content present in a body is called enthalpy. So it will be an endothermic process, and the enthalpy will be positive enthalpy enthalpy. Okay, so positive enthalpy will be there because it's a endothermic reaction. So this energy is required F1450 to remove electrons from an ion of a magnesium and convert it into 10 electron. Now there are 8 electron in this shell. Okay, here in the L shell. Okay, this one is the L shell. So here we are having 8 electron. It is following the octet rule. Octet rule is a rule in which an atom has means least electron of 8. When it is having the 8 electron, then it is a stable atom, you may say. Okay, so it is applying octet rule, and now it is balanced. So if we need to remove this electron, then we have a means we have to give a lot of energy to it to remove this one electron. Okay, so now let's means explain some points according to the periodic table. So means down to the group electron ionization energy decreases. So how it will be decreasing, I will be telling you. And across the period from left to right across the period, right across period across period, the ionization energy will be increasing. Okay, the ionization energy will be increasing. Okay, so ionization will be increasing from left to right. So for example, if we are having means we are having helium. Okay, it belongs from the noble gases, means it is a stable. So we if we want to remove the electron from the sodium, means K shell, and if you know that K shell contains 2 electron. Okay, so it is stable here now. So if we want to remove this one electron from the helium atom, if we want to convert this helium atom into this one He plus, so we have to give a lot of energy because this one helium requires that sort of energy which is means not available in earth. This reaction usually happens only at sun. It cannot happen on the earth level. So it usually happen at the earth level. So because of this is the reason that many people would say that ionization energy is the property of a metal. Why they used to say? Because uh, metal used to means ionize easily on earth, but like, non-metal like we have got the example of helium, it never means converted into He plus because it never loses electron because we do not have that sort of heat present in our earth. So usually it uh, do not happen at the earth level. Okay, and it is from the earth group. So you may see this that from left to no from yes, from left to right across the period, electro ionization energy will be increasing, and you have seen that there is a lot of energy. Even there is not any place in Earth to remove electron from the valence shell of helium. So now comparing with the a metal, comparing with it a metal which is a okay, leave sodium. Lithium is a metal in which it is having one electron in the valence shell. It is having three atomic number. Okay, three atomic number means three electron. It is present in the shell. Okay, so lithium is having two electron in the first shell and one electron. If lithium want to lose electron, so we can give a bit of energy and it will lose electron easily. So means that's the concept. Lithium is losing electron very easily as compared to any other non-metal. So this is written here that down the group electron energy, ionization energy will be decreasing. So means if we compare lithium towards means francium is having it is means having a lot of big size at big size in the atomic, it is having a big atomic size. So because of that it can lose means electron very fastly than helium, because it is having a low nuclear force. Low nuclear force. And why it is having low nuclear force? Because it is very far away from the nucleus, so it will lose electron easily. Okay, so now we will be going through electron affinity. Electron affinity. Okay, affinity. So basically electron affinity is the means you may say is the reverse process of ionization energy. How it is reverse? Because as we know that in metals we we have ionization energy, we can do ionization energy very easily because they have only one electron in the valence shell. But as we are comparing with non-metal, so non-metal do not used to lose electron very easily. So electron affinity is the process in which any atom gains electron, and you know that every metal used to lose electron, they do not wanna gain electron. Okay, so electron affinity usually happen in the gases which needs an electron to complete its outer shell. For example, electron affinity, like we got chlorine here, it is having 7 electron in the valence shell, so it will try to get electron from the valence shell of any atom. So any atom, okay, uh, then it will be gaining this electron. Okay, so this process, when the chlorine is getting electron from any atom, here we got sodium, so this process is called uh, electron affinity. Okay, negative charge will be appeared because it is gaining electron. So let's look at the meaning of electron affinity. So electron means a negative charge particle which is an electron, and affinity means love. Okay, so electron affinity, so the basic meaning of electron affinity is this, that loving to get electron, loving to get electron. You never means have studied this concept, and now I will be telling you that what is it actually. For example, if there is a person who want to buy means an ice cream, a cone ice cream is there. Okay, you want to buy this one cone ice cream. Okay, and it is having means $5 rate. Okay, it is having a $5 rate. So how will he can buy this? So to buy this one ice cream, he needs, means he want to get, if he want to get this ice cream, So he need to means do something work. To do work he need to lose energy, because if he will be doing work, he will be losing energy, but in result it will be losing energy, but in result he will be gaining some dollars, and with that dollars he will be buying ice cream, ice cream, ice cream. Okay. So when he will be buying ice cream after losing energy, so his aim is to just buy ice cream. He do not want to means say that I don't want to lose energy, I don't want to get energy. His aim is to buy this one ice cream. Likewise in the non-metal atoms, like we got chlorine is here, so we can get another non-metal. So like hydrogen, not not the example of hydrogen, and there are other, I don't know why I'm not getting an example. So here like hydrogen 2, and it is having 7 electron. Okay, 5. Okay. So if you look at the means the structure of nitrogen, it is having means 3 electron is required to remove its valence shell. So how he will be how it will be getting, so it will be getting from another element. He don't know that I want to lose energy, I want to gain energy. So means it will be getting means there are free electron, 3 electron, so he will be getting one by one. Okay. So when he will be getting these 3 electrons, it will be stable. So atoms wants to be stable in octet rule. So this the first purpose of their life, you may say. They want to stable in their zone, so because of that they used to gain electron. For example, have we got the oxygen, and if when if for example if we have oxygen, and oxygen will have the valency of -2. Okay, means it requires 2 electron. So when it will be getting 2 electrons, here we have 2 electron, so it will be like this. Okay, to O minus 2. Why it have got 2 electron? So for example if we were having only 1 electron, then it will be getting like this -1. Okay. As you know that element do not contain a charge, but when it will be gaining an electron, then it will be getting a charge. For example, the energy which was means released in this reaction was minus delta H. I don't know what was the energy here. Okay. So this minus delta H means the energy which has been released is called electron affinity. Electron affinity means the energy which will be releasing in the reaction when the non-metal atom will be gaining. Not only non-metal atom, anyone can gain electron, and if the energy is losing from there, so it will be calling as the electron affinity. Okay. So here we are having means after electron affinity, I want to write the clear definition of electron affinity. Electron affinity is a process in which um, it usually happen in non-metal. Okay, like ionization energy usually happen in the metals. Okay, electron affinity is the process in which we in which not we in which a non-metal gains an electron, gains an electron and releases energy, and releases energy to and releases energy, and that energy is called electron affinity. So simply this was the concept of electron affinity. Okay, so hope you guys enjoyed this one, but we have still one more topic remaining, which is factors affecting the ionization energy. Okay, we will be discussing the factor affecting electron affinity in the very next video. Okay, so let's look at the means affecting uh, factor affecting ionization energy. Okay, ionization energy. Okay, let's look at it. So we have got two factors here. In federal we are having three factors as well. Okay, nuclear force. Okay, here we are having nuclear force, and here we are having another force which is called I forgot it till now. Okay, so if the atom is having like yes, here we are having orbital size. Okay, okay, or you may say atomic size, not orbital, orbit, how many orbits are present. Okay, so nuclear force, for example, if we are having 11 proton in an atom, like in the atom of sodium, and it is having one electron here. Okay, so it as compared to the 12 proton of magnesium, 2 8 and 2. Okay, so the means nuclear force will be more higher in magnesium as compared to sodium. Okay, so cause of that means 12 protons, means number of proton is directly proportional to nuclear force, and because of that it will be having means low ionization energy. Low ionization energy is compared to sodium. Ionization energy is compared uh, to sodium. And here we are having another which is like, as we are having francium. Okay, here we got one electron, and as we are having sodium 1 2 3. Okay, it is having one electron here. So to remove electron from this valence shell is very easy, and to remove electron from here it is a bit of hard because it is near to the nuclear, and here is a more nuclear force. Okay, so because of that atomic size also dependent on the ionization energy, because it is having ionization energy depends upon atomic size, because it is having a lot of atomic size, means for example nucleus is here, so it is far away from nucleus, and here nucleus is here, so it is means not away from nucleus, it is having a low distance than this one. So ionization energy is higher here, higher than the first one. Okay, the first one. Okay, so hope you guys enjoyed this lecture. We'll see you in the next video, and if you are means liking this video, then comment below. I will be making more video like this one. Okay, we'll see you in the next video.